facilities where we can train European astronauts what to do on the moon. And so in Cologne, we will now have the moon training facility, which will enable to do all this training over there. And it will be so good that even hopefully the NASA astronauts will come over to train there for their Artemis mission. So that's the big vision that we have. But it's not only learning for the moon. We also should also keep in focus that we have European astronauts flying to the ISS. Andy Mogensen is getting ready to fly later this year. And we just started a new astronaut class. They will be flying to the ISS, hopefully, and to whatever comes after the ISS.
So do you imagine yourself taking off from here from the European spaceport here in French Guiana one day, Matthias?
Yes, we are currently in times that are really like a revolution in space. And so Europe needs to step up. And one of the big missions that we have, we need to become sovereign, to become autonomous, also with access to space for Europeans from European soil. And I think French Guiana is the ideal place to send Europeans on a European rocket in a European capsule to space. It's our big dream. Thomas and I, we would love to fly together from here to low Earth orbit, but maybe even also in a European rocket further towards the moon.
And you said you'd be happy to welcome your NASA friends as well.
Absolutely. I mean, it's we should not forget spaceflight is also a soft diplomacy power. And we will see very soon that China will invite foreign astronauts to fly to their space station. And so we Europeans, we are just learning that in these times it becomes more and more important to be on level field playing. And spaceflight definitely is also an important part in the diplomacy area.
Huge thank you, Matthias. And we have with us Josef Aschbacher. You are the Director General of ESA. Thank you for joining us. So in a nutshell here, what we've been talking about is Europe's capabilities for independent launch. Are you going to make this happen? You have 15 seconds.
It's not for me to make it happen. It's all the others to make it happen. But certainly we have been working very hard on it. We have consulted experts, independent experts, to help us giving advice what this would mean for Europe as a unity of all the countries, the inspiration we would give, the economic benefits, the geopolitical strength that would be portrayed through such an activity. So there's a lot of interesting facets, and you have just heard Matthias and Thomas talking about those because it's so important, and yes, we are working on it. But let's talk about JUICE because that's why we're here. Also another excellence where Europe is really good, and let's look how our satellites and our launches are doing.
Thank you very much, gentlemen. Huge thank you.
Thank you.
And to talk about JUICE, I am joined by Raphael Chevrier from Arianespace. Raphael is going to take us step by step all the way through every step of the mission. Raphael.
Hello, Liz.
Hello. Welcome to Road to Space, and I'm going to let you take over from here and tell us what the next steps are.
Yes, so this morning we are launching towards the east, where we benefit from the slingshot effect given by the rotation of the Earth. So the launcher performs a first pitch maneuver in order to get us into the right direction. And only 2 minutes and 17 seconds after liftoff, the two boosters have done their jobs of providing the main thrust, so we don't need them anymore, they are detached from the launcher. Shortly after that, the fairing, which protected the spacecraft from the environment of the launch, is also jettisoned as we have crossed the limits of the atmosphere. Once the launcher reaches an intermediate orbit, the main stage is cut off and separated. So then the upper stage takes over, which engine is going to power for about 16 minutes in order to raise speed and altitude and release juice on the targeted orbit. So, by the way, the little towers that you see on the motion picture, they represent a chain of telemetry stations that are receiving data from the Ariane 5 in real time all along the flight path. After some orientation maneuvers, JUICE is separated on a liberations orbit. It means that it will have the required speed to escape literally the gravitational pull of the Earth. Then this is almost the end of the mission from the launcher, as we still need to perform some disposal maneuvers of the upper stage, but JUICE is only beginning its journey. ESA teams will use the Norcia ground telemetry stations in Australia to acquire the signal from the spacecraft and take full control of it. 1 hour and a half after liftoff, Joule will start deploying itself like a butterfly into space. First, it will unfold the large solar panels. Their total surface is 85 square meters. This is definitely bigger than my Parisian apartment. And then, in the following days, it will deploy its many antennas and probes. So the animation here doesn't depict the increasing altitude that JUICE is going to get, getting farther and farther from Earth on its way to its 8-year journey to Jupiter.
Thank you so much, Raphael. It's all very clear. And actually, as Raphael was speaking, so you can see the pictures of Ariane on the launch pad. As Raphael was speaking, we hit the next milestone in our in the chronology, which is, of course, the -10 weather update. And
Yes.
I'm looking at the board. All is green. I
All
have
is
not
green right
heard
now.
anything in my earpiece. I don't see anyone picking up a mic. So it's looking good so far.
It is green and we're good to go.
Looking good to go.
What we check, like Stefan said, we are usually checking the wind at high altitude, the wind in the vicinity of the launch pad, and also the risk of lightning. Yesterday, it is the risk of lightning that prevented us from launching, but today, everything's good. We're good to go. We can continue the operations.
That sounds great. And continuing the operations means that we're heading towards what we call the synchronized sequence. We'll talk about that in just a minute. So there's another team. You see the teams working here. Final preparation on the way here in Jupiter Control. But of course, there's another team at the Launch Control Center, which is much closer to the launch. It's about 4 kilometers to the launcher. And they've been working since last night. So they've not slept. Tell us more about them.
Well, these teams are monitoring all the operations during the final countdown. So, for example, they are filling the cryogenic stages. They are cooling the Vulcan engine, that's the main engine of the launcher. They are pressurizing the upper stage sphere.
This is them hard at work in the morning.
Exactly, and I think the images were shot this morning actually. And so it's all these operations that are leading us to the start of the synchronized sequence.
So what is this synchronized sequence, Raphael?
Well, it's a real crucial step.
You have 30 seconds.
Yeah, so I'm going to make it very quick. It's basically a succession of operations aimed at giving more and more autonomy to the launcher and to set it in its flight configuration.
Yeah, because
30
it's
seconds.
an irreversible. Once we've started the synchronized sequence, we can't go back.
No,
That's the
so
point.
we are going.
Absolutely. And we're going to now wait and hear.
À tous de DDO,
Right.
attention pour le début de la séquence finale lanceur. Top H0 moins 7 minutes.
So there we heard it from the DDO, who is the Range Operations Manager. We'll talk about him in a minute. And he's just announced the start of the synchronized sequence. Just a quick question. Why does it have to happen at -7? We were just saying.
Well, I mean, this is obviously not a magic number. This is just the time for all these last minute operations to be performed. For example, we are topping up and pressurizing the tanks. We switch the power supply from ground to board, and only then the launcher is going to be fully awakened for launch.
Fantastic. For those who are joining us, we are 6 minutes and 20 seconds to liftoff of Ariane 5, carrying JUICE on the first leg of its journey into space and towards Jupiter. As Raphael was saying, Ariane, we were talking about this earlier, Ariane normally launches 2 passengers, but this time it's a single passenger. So can you just go quickly into what difference that makes for the launcher?
For the launcher, this is a very precious passenger, but for the launcher, it remains exactly the same. You have the 2 lateral boosters, you have the main stage, you have the upper stage, 1 fairing. We are also launching towards the east, which is the same direction as for standard telecommunication satellites. Only the final destination is a bit different. This is Jupiter. It is the last time that we performed such a single configuration. One of the last time was for launching the Space Telescope James Webb. Let's hope today is going to be as flawless and smooth.
Absolutely. And let's quickly now go into the film and have a look at the last couple of months of launch preparations.
4 months ago, key elements of the Ariane 5 rocket arrived by boat on the coast of Kourou. They were carefully transferred to Europe's spaceport in large containers. These elements were then assembled in a dedicated building. Here we see the main core being placed into a vertical position, standing 31 meters high. The two solid boosters were attached to either side of the main stage. This was followed by the upper cryogenic stage, hoisted into the air and lowered onto the main stage. The whole assembly was then moved to the so-called final assembly building. JUICE arrived last February by plane in Cayenne, the main city of French Guiana. It then traveled an additional 50 kilometers to the spaceport for preparation. There, the spacecraft was removed from its container and carefully inspected in clean room facilities. JUICE was then integrated onto the launch adapter before it was fueled, bringing its weight to just over 6 tons. The spacecraft was transferred to the final assembly building and mated on top of Ariane 5, some 35 meters above the ground. Launch preparation team got their last glimpse of the spacecraft as it was encapsulated inside the fairing, which has kept it safe and sound until today. On Tuesday, Ariane 5, with JUICE on top, was rolled out to the launch pad, where today it waits, poised in anticipation for its ascent into the sky.
So, our passenger is sitting safe and sound, tucked under the fairing, as you can see, waiting for liftoff in just over 2 minutes.
Raphael, I have moved to the skybox overlooking the Jupiter control room, where, as you can imagine, everyone is intensely focused on the last couple of minutes to lift off. And we can see here, as I was telling you, the crowds that were sitting in Jupiter control have now been asked to go out to the terraces on either side of the control room. They are among the lucky... Oh, so I didn't realize you could actually see us. We're sitting here in our skybox. So they're out on the terraces. And they will be the lucky ones who'll be able to see and also feel that launch, because trust me, you feel it. What are we going to see in the last few seconds before liftoff, Raphael?
Well, everything is going to happen quite quickly. So, like I said, the electrical power supply switch from ground to board, the cryogenic arms which are feeding the upper stage with fuel, we see them retract 6 seconds before liftoff. The Vulcan engine will ignite first. We need to check it's working properly before we switch on the boosters. That's going to happen 7 seconds later. So don't be surprised if you don't see anything during these 7 seconds, because believe me, you will see and you will hear the launch.
And you'll be hearing every milestone being called out by the DDO. He is the Range Operations Manager, and his role is in an... Oh, we'll wait for the 1 minute mark. Raphael.
À tous de DDO, attention pour moins 1 minute. Top H0 moins 1 minute.
Right, so from here on, no more commentary from us. Don't be surprised if it doesn't take off immediately, because of course there are those 7 seconds, Raphael.
Exactly, so just enjoy the launch.
During which the Vulcan engines are set on, and then the launcher takes off.
Go Ariane 5.
Go Ariane 5. Enjoy.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage AP, décollage. La propulsion est nominale. La propulsion est nominale.
And there we go. We've seen the Ariane 5 lift off, roaring through the tropical sky, carrying JUICE on the first leg of her journey into space. And now she has disappeared under the crowd. And see there, in Kourou, there are many places from which to watch these launches. As you can see, the beach, any place. And here we have a glimpse again of the rocket. Raphael, it's an amazing sensation for you as well, I'm sure.
Yeah, even with the clouds, it's just...
La trajectoire est nominale, tous les paramètres bord sont nominaux.
It's really, really always impressive, and it's an emotion to see it. So the DDO said that the trajectory is nominal, which means that it's working perfectly, it's going as planned.
La propulsion est nominale, le pilotage est calme.
And in fact, just to sum up what the DDO does in 3 words, his responsibility, he's the person who calls out every milestone along the way, and he's in charge of providing information on propulsion, guidance, and trajectory.
Exactly, he's like an orchestra conductor, gathering all the informations and summarizing it in real time, and soon we'll have booster separation.
We're waiting for confirmation from the DDO.
Séparation des EAP.
So the boosters have been safely separated. This is great. They have provided 90% of the overall thrust of the flight, so they're doing the main job. And then soon we'll have the separation of the fairing. And by the way, you see a special drawing on the fairing right here. Children around the world were asked to submit artwork
La trajectoire est nominale.
inspired by JUICE's epic journey, and on this fairing we see one child's interpretation of Jupiter embracing our spacecraft. Everything is nominal.
Tous les paramètres bord sont nominaux.
All parameters are going smoothly.
And there we have it. We've seen it in our 3D
Séparation
animation,
preuve confirmée.
and we've just heard it from the DDO.
Confirmed. So the fairing was used to protect the satellites from the friction of the air, but also from the noise generated during the ascent phase. We obviously need to safely separate the fairing, otherwise we would not be able to release JUICE into space.
La propulsion est nominale.
It also means that we have crossed the limit of the atmosphere. So JUICE is on its way to be separated in about 24 minutes from now. So by the way, we will have so the separation of the cryogenic stage when it has placed the launcher on an intermediate orbit. After this, I can mention that during, and we can actually see it on the motion design, because this is 3D animations here, that during the ascent phase, the launcher is set in what we call a barbecue mode. So it's slightly rotating on itself at a speed of 0.7 degrees per
Le
second.
pilotage est calme, la propulsion est nominale.
So we do this so that every face of the satellite is equally exposed to the sunlight. We just want to avoid overheating in one particular side of the spacecraft, which could damage the instruments. And as a matter of fact, when the upper stage is going to be injected on the targeted orbit, it will also rotate at a speed of 0.5 degrees in one direction, and then at the same speed in the other direction. Again, to avoid overheating on one part of the spacecraft, exactly like, a barbecue.
Exactly. And of course, there are the onboard computers. What are they measuring right now, Raphael?
Well, they optimize the trajectory.
La propulsion est nominale, le pilotage est calme.
Everything is nominal, so they optimize the trajectory in real time. They minimize the propellant consumptions to bring the launcher to the intermediate orbit, targeted at the end of the main stage propulsion phase. And as a matter of fact, we are accelerating a lot right now. So within the next 3 to 4 minutes, we'll go from, 3.5 kilometers per second to more than 7 kilometers per second.
So how much is that per hour? Because you're the engineer.
25,000 kilometers per hour. And ultimately, juice will be separated at a speed of almost,
le pilotage est calme.
10 kilometers per second. And it will be separated at an altitude of 1,533 kilometers.
Very precise. Okay. So the next milestone we are now waiting for, and we'll be hearing this again from the DDO, is the acquisition by our downrange station of Natal. That is located in the on an island in the middle of the Atlantic. I'll just wait and hear that from the DDO. He may not have confirmed it orally, but by now it is.
Just to explain, all along the route eastwards, Ariane is tracked from the ground. So the launcher's functions and vital signs are recorded and sent back to a network of stations that keeps constant watch on the health of the launcher systems.
Par la station télémesure de Natal.
And we have
it.
The
And
confirmation that the first...
Apologies, of course, I did not mean Ascension. I meant Natal, over the border in Brazil, of course. That's the second downwind station.
And just so you know, in all, that's about 1,500 parameters that is collected.
Collected, my goodness. So that there's no way these 1,500 parameters can be analyzed in real time, Raphael. What happens to them?
Well, the complete analysis is carried out in the weeks following the launch by a dedicated team. They provide a wealth of information about how the vehicle performed during its mission. And so this is why we constantly, improve our knowledge of a launcher, launch after launch. And then that's why Ariane 5 is such a reliable launcher.
And so you were talking about the stations, and it's a little bit, you were saying to me earlier when we were chatting, it's like a relay race, these stations, isn't it? These downrange.
Yeah.
You were listening to the DDO. What did he say? I didn't hear him.
He said that all the parameters are working perfectly.
Nominal, that's what we like to
So
hear.
the flight is perfectly smooth. So yeah, this is like a relay race with one telemetry station passing the baton to the next one, because we want to keep full visibility of the launcher in all dynamic phases of the flight. So the first stations to pick up the data was Galileo, right here in Kourou, followed by Natal in Brazil, then the island of Ascension in the middle of the Atlantic, and followed by Libreville in Gabon, and finally Malindi in Kenya.
As the launcher crosses
Trajectoire
Africa.
nominale, tout paramètres nominaux.
So we'll have 3 different, very short sequences right now.
Coming up.
The cutoff of the main stage.
We should hear that.
The jettison of the main stage. And then the ignition of the upper stage. So it should be confirmed.
Extinction Vulcain. Séparation EPC.
And the ignition coming up.
Yep. Waiting for the
Allumage
confirmation.
ESC confirmé.
That's a very good news. That's a very
You
important
should see the
step
smile on
towards the
Raphael's
start.
face. You can't, because we're in our little booth. Because we forgot to mention that we are now in the sky booth, where we have a fantastic view over Jupiter, where we can see the crowds gathered. And yes, and so you cannot see the smile on Raphael's face, but he is delighted that this stage has gone perfectly.
Yeah, the ignition of upper stage is absolutely key, because it's always quite a little bit tricky to ignite a liquid stage in the emptiness of space. Sorry, I told you that on the ground we wait for a few seconds to check that the Vulcan engine is correctly ignited
Fin de visibilité par la station de Galileo.
before liftoff. But in space, it's just not possible to do that. You cannot send somebody to repair the engine. Also in zero gravity, the propellant is floating in all
Le pilotage
directions.
est calme.
The thermal environment is also not the same as it is on the ground. So, you know, there are many factors that make it quite
Trajectoire
challenging
nominale, tout paramètres bord nominaux.
and complex to ignite the engine in space.
So we were mentioning earlier, this is the penultimate Ariane 5 launch, which for more than a quarter of a century has provided Europe with reliable and independent access to space, which Josef Aschbacher was talking about earlier. Ariane 6 will be taking over. Europe's best engineers are building on the success of Ariane 5, and there's already a fully integrated Ariane 6 on the launch pad right here in Kourou. You're going to tell us about that, Raphael. So can you take us through the latest developments
Absolutely.
with Ariane 6?
So last year was quite exciting for Ariane 6 with the start of what we call the combined test, corresponding to the meeting between the launcher and the launch pad here
La
in
trajectoire
Europe
nominale, tous les
spaceport.
paramètres bord sont nominaux.
Here we see a fully representative version of Ariane 6, which has been assembled with the main core raised vertically, directed on the launch pad. The upper composite was then hoisted and mated on top of the launcher. This operational scheme is actually a big difference with respect to what is done with Ariane 5. It is made possible thanks to this mobile gantry, which will obviously be removed during launch. And also, 2023 is going to be also a busy year for Ariane 6, obviously. In January, the launcher was connected to the control bench, and a first power test was performed. Then dry run will be performed, followed by the actual fueling operations of the central
La
core.
trajectoire est nominale, tous les paramètres bord sont nominaux.
Teams will also perform hot firing tests of the lower stage engine, Vulcan 2.1, including a long firing test. And hot firing tests of the upper stage were successfully performed in 2022 and beginning of 2023 in Lampershausen at the German Aerospace Center. Next ones
Pulsion
are
nominale,
under
pilotage
preparation.
calme.
So launcher elements that will be used for the Ariane 6 first flight will arrive in French Guiana using the new generation canopy vessel, which will be equipped with sails and hybrid
La
propulsion,
trajectoire est nominale, tous les paramètres à bord sont nominaux.
so that we can start the first real launch campaign of Ariane 6. And so today, the prototype of Ariane 6, stands on the launch pad, ready to continue the combined test. So good luck for this very ambitious and incredible program.
And Raphael, we heard while you were explaining all of this, we heard that the DDO called out the loss of signal with the Natal tracking station.
Suite à
Now,
la fin d'acquisition par la station de Natal.
there we go. And we didn't hear that it had been picked up by the next station. Is that normal?
This is perfectly normal to have short visibility holes during non-dynamic phases of the launch. In this case, we have no visibility for just 63 seconds before the Ascension ground station picks the signal back. So this should come in any seconds now.
Acquisition de la télémesure par la station d'Ascension.
Your timing is perfect.
Confirmed.
So we've been picked up by the next downrange station, that is Ascension, the tiny little island in
La
the
trajectoire est
South
nominale,
Atlantic,
tous les
and
paramètres à
everything
bord
is
sont nominaux.
nominal, the DDO is telling us. So from what I understand, we're going back to Ariane 6, there's a very healthy order book already for Ariane 6 launches, Raphael.
Yeah, Ariane 6 is already quite successful on the market, with already 28 launchers sold for both institutional and commercial customers. It is a very versatile, flexible launcher, perfectly suited for complex missions and satellite constellations deployment thanks to its high lift-off capability and its reignitable upper stage engine.
La trajectoire est nominale, tous les paramètres bord sont
There we
nominaux.
go. It's nice to hear the regular updates from the DDO that everything is going to plan. For those of you who are joining us, Ariane 5 lifted off 14 minutes ago, just over 14 minutes ago, from the European spaceport here in French Guiana, carrying ESA's Jupiter Icy Moon Explorer into outer space. We're bringing you this live show from the Jupiter control room, where the operational teams are overseeing the mission's progress. JUICE is due to separate in about 13 minutes' time, but this is just the start of its long journey on its way to Jupiter. Let's find out more about the tech on board that will help it fulfill its mission.
La propulsion est nominale, le pilotage est calme.
At the heart of the JUICE mission, led by ESA, is a giant bird-like spacecraft with large solar panel wings stretching out on either side of its main body. With a mass of 6,100 kilos at launch, JUICE is a heavy spacecraft carrying 10 high-precision instruments, including the most powerful remote sensing, geophysical and in-situ payloads ever flown to the outer solar system.
Building a spacecraft which has to fly around Jupiter is a challenge. To operate a spacecraft you need energy, you need power. And normally we get power from the sun using solar array. But around Jupiter there is not much sun. Therefore the solar array has to be very big. There is also another challenge. All the stuff that we built there has to survive very low temperature. And the third one is that the environment around Jupiter is very radioactive. That's why I think the solar array, which is very exposed and put together these three difficult technology, is really a great piece of engineering. Maybe a piece of art.
The instruments were contributed by the JUICE mission's scientific partner. The spacecraft was developed and built by Airbus, and Ariane Group's Savoir-Faire equipped JUICE with the chemical propulsion system that will drive it to Jupiter and its icy moons on an 8-year cruise.
We
will provide the propulsion system for JUICE, which ensures that after leaving the launcher, it arrives correctly at Jupiter's moon and can work properly there. It's a fascinating thing, especially because the technical requirements of such a long journey, with so many constraints to consider, challenge each of us in a unique way.
Engineers have devised advanced technological solutions so that JUICE can operate in extreme environments, face Jupiter's high radiation belt, the long distance and harsh temperatures. Its 2.5-meter diameter antenna will send the data JUICE collects back to mission control, although it can take close to an hour to travel to Earth. The European mission JUICE is going to be a real revolution. Its collection of valuable data will be used by scientists for years to come and help unlock some of the greatest mysteries of the universe.
So, Raphael, JUICE is an emblematic European science mission. So what is it about this particular mission that inspires you as a rocket scientist?
Well, dream. And dream has always been a very strong driving force.
Acquisition par la station télémesure de Libreville.
For me, but also for, I think, everybody who works in the space industry. And, if we go on a more personal note, actually, before working at Arianespace, many years ago already in my life as a space writer, I remember that one of my first real article I wrote was about Jupiter's icy moon and the preparation of the JUICE mission with a focus on the moon Europa. And you can imagine that I would have never thought back then that I would be here standing at Kourou Spaceport in the Jupiter room to comment on its deployment into space. And I think I'm not mistaken when I say that all my colleagues are inspired by such emblematic mission. It really gives us an extra boost each time.
And especially when it comes to a mission aimed at looking for signs of life. That is just something else. It's difficult to actually fathom.
Can you, I mean, yeah, the ambition of JUICE, and it's a very complex mission, by the way.
La propulsion est nominale, le pilotage est calme.
So everything is nominal, but thinking that one probe is going to be around the moons of Jupiter, which are unexplored worlds with oceans of liquid water under the ice surface.
La trajectoire est nominale, tous les paramètres bord sont nominaux.
Where exobiologists expect to find some forms of life. We don't know, like microbes, maybe shrimps, maybe small fish. Probably not, but let's dream. And especially on the moon of Europa, it's just absolutely incredible.
Indeed, Raphael, hundreds of professionals in Europe are working on this crucial mission. We met some of them earlier, and as we know, it takes a whole family to put such an expedition together. So let's hear from some of the partners of this mission.
Bonjour, je m'appelle Victoire de Maincourt, je suis nationalité française, je viens de Toulouse, je travaille chez Ariane Espace.
My name is Rossella and I originally come from Italy.
My name is Oliver Troll and I'm a German rocket engineer working for Ariane Group in Bremen.
I'm Italian and I'm a telecommunication engineer.
Je suis espagnol, je viens de la ville de Madrid. Et ça fait 3 ans que je travaille au Centre spatial guyanais.
Je suis chargée du suivi en temps réel du lanceur et de la mission et de vérifier son bon déroulement afin de rassurer à la fois les personnes qui travaillent sur le lanceur et évidemment le client.
In Kourou, during the launch campaign of JUICE, our goal is to check all the final full functional tests, so all the final checks after the transport of the satellite here in Kourou and before the launch.
I'm responsible for the follow-up of the stage integration up to the launch, the treatment of technical anomalies with an end-to-end view, the technical consistency of all information, and the on-site presence in Kourou during launch campaign.
Je travaille à la sauvegarde vol. Mon rôle le jour J consiste à surveiller la trajectoire du lanceur et les équipements à bord. Et si on constate que la mission cesse d'être nominale, on pourrait être amené à intervenir pour assurer que tout se passe en sécurité pour les viandes et les personnes et ainsi maîtriser les risques.
I take care of the assembly and integration of all the units of the spacecraft and afterwards to make sure that the test campaign goes as planned and that the spacecraft will perform as expected once in space.
If I want to define team spirit in 3 keywords, I can say that the first one is collaboration, the second keyword is coordination, and then the third keyword, which is the most important for me, is to have fun. It helps overcoming difficulties and obstacles. So yeah, for me this is the most important part.
So we are coming up to 22 minutes after liftoff, which means that in just over 5 minutes, JUICE will be separating from the mothership and starting its own life in space. Raphael, can you give us an update on where we're at right now?
So everything is working perfectly.
Acquisition par la station télémesure de Malindi.
So we have the Malindi telemetry station acquisition. So in the past 5 minutes, we went from 190 kilometers to more than 500 kilometers of altitude. So it now has a speed of 9.6 kilometers per second, which is absolutely gigantic. It is almost the speed at which JUICE will be separated into space. During the next 5 minutes, we'll increase altitude even faster. We'll gain an additional 1,000 kilometers in altitude. And by the way, the weight of our structure right now is 14 tons about, only 2% of the initial mass of the Ariane 5 when it was on the ground.
That is just unbelievable, 2%. Ariane 5 typically launches geostationary transfer orbit launches, so here we're sending JUICE obviously much, much farther on an escape orbit. How is this different? How does it differ, for example, from launching a telecom satellite, which are many of the satellites that are launched with Ariane 5?
Well, the energy to provide to the spacecraft by the launcher is higher. It needs to escape the gravitational pull of the Earth. Also for geostationary launches, we usually have a launch window of typically 30 minutes to 1 hour and a half, let's say, during which we can try and launch. And today's mission is sort of a rendezvous mission. And there was no launch window. It was what we call an instant launch. So we had to launch an exact time. So this is why everything has to go smoothly, even the weather before launching. Also, geo launches to the geostationary orbit usually happen in the evening. Today we launched in the morning, meaning that the team have been working all night during the final countdown. And also, we had to slightly adapt the filling of the tanks of the upper stage with cryogenic propellant, as the launcher was exposed to the sun since early morning, 6 a.m. So the sun heats and increases the pressure of the tanks, so we had to slightly underload it by 120 tons, which is kilos, sorry.
So how is it this mission in itself different in terms of preparation?
Well, we needed to take extra care in terms of cleanliness, because before leaving the Earth, we want to know exactly what kind of biological material JUICE takes with it. In French Guiana, there were several institutes which took samples from JUICE in the various satellite preparation rooms. Of course, most of the microbes will be sterilized in space, washed out by space radiation, but some can survive. Here we see on the image His Majesty the King of Belgium and His Royal Highness Prince Gabriel, who...
And they are here as VIP guests because Belgium has contributed rather importantly towards preparations for JUICE. So we were talking about, we were looking at the difference in preparation, weren't we?
The second main difference is that, you know, JUICE will perform very precise magnetic field measurements around Ganymede, the moon of Jupiter. And we had to measure many times the magnetic environment of JUICE during the launch campaign on the ground to make sure that in space it will measure only the magnetic environment of Ganymede and not its own magnetic field.
Because it has a very, very strong magnetic field, of course.
Exactly.
Okay, and so in a nutshell, looking at the time, we actually have, I haven't heard it from the DDO, did you?
So right now, we are in the stage where the upper stage is performing slight orientation maneuvers to separate the spacecraft in a very specific direction. It's important to do so on time in a very precise way, as it will really drive the satellite injection accuracy and have an impact on the rest of the spacecraft's lifetime in space. Just to give you an idea,
manœuvre d'orientation au profit de JUICE se poursuit de manière nominale.
Trajectory correction maneuver. And so the better the injection precision, the less important the maneuver is going to be, meaning that JUICE will be able to save its precious fuel for the rest of the mission.
And Raphael, we are 30 seconds away from separation. What are we going to see exactly? And then we'll stop the commentary and wait for the moment. In a nutshell?
Well, let me remind you that this is 3D animation here, but the teams are receiving signals and information in real time, and it is them who will confirm the separation of JUICE on its liberation orbit. They will provide all necessary information to ESA teams so that they can acquire the spacecraft.
Let's wait for confirmation from the DDO.
Séparation JUICE confirmée.